The force on a charged particle moving in a magnetic field is given by F is equal to Q V cross V, where V is the velocity, V is the magnetic field, and Q is the charge on the particle. Now this says that the force has to be 0 because the proton does not get deflected. So if the force is 0, that means that V cross V has to be 0. Now V cross V is equal to magnitude of V times magnitude of V times sine theta. This means that sine theta equal to 0 gives a possible condition when the force on the charged particle is 0. So if sine theta is 0, that means that the charged particle has a velocity v and it enters in the direction of the magnetic field. This is the direction of the magnetic field and this is the direction which the charged particle moves. So the answer to this question would be sine theta equal to 0. Now just a little bit of extra information in this. Say you have a magnetic field in this direction and a charged particle enters in this direction, which means the angle between the velocity vector and the magnetic field is 90 degrees. In that case, the charged particle will move in a circular path around the magnetic field. It's like the charged particle starts going around the magnetic field. Now, this is if it enters in a horizontal direction. Now, let's say the charged particle enters the magnetic field at an angle. So, say this is the velocity vector. In this case, we will resolve this velocity into two components. One is in this direction, which is perpendicular to the magnetic field, and another in this direction, which is parallel to the magnetic field. Now, due to this component of velocity, which is perpendicular to the magnetic field, the charged particle will execute a circular path. But due to this component of velocity in the vertical direction, it will also have a component in this direction, so the path will become helical. And the velocity in this vertical direction is this vertical component which is parallel to the magnetic field. So in this case, the path will be helical, whereas if it is completely perpendicular to the magnetic field, then the path will be circular.